committee. And if I could get the slide to advance, there we go. The slide is advancing now. Sorry about these technical problems. This is what we're going to cover in the webinar, both me and Joe. Comparison of the selected ASHRAE ventilation standards. Many of you are working with the Building Performance Institute, and they are in the process of changing over. Also, there's some other organizations that are requiring the ASHRAE standard. I'm going to talk about the programs requiring that, a little bit about the ASHRAE standard and the BPI 1200 standard, Section 8 in that BPI standard, which is essentially the same as the ASHRAE standard. It's just written in a different way. I'm going to show you the differences in character between balanced and unbalanced ventilation. What I mean by balanced ventilation is a heat recovery or an energy recovery ventilation device where we might have 50 cubic feet per minute of air being exhausted from the house and simultaneously 50 cubic feet of air being supplied to the house. So it's
Rick,
balanced.
I need to interrupt you. We're getting some
Yes.
comments about the sound drifting in and out. If you could speak up or readjust your microphone.
Okay. I hope that's better.
Yeah, that sounds better.
Okay, good. Unbalanced ventilation, I think many of you are accustomed to. It's the least expensive type of ventilation to install. Exhaust-only ventilation, so I'll say something about that. Joe is going to talk quite a bit about the ways of measuring. That's a great treat in this webinar. He's going to show you different devices. And if we have time at the end, we'll do some calculations with the ASHRAE standard using the RETROTEC free tool. Okay, I'm getting, all right. Is my screen still on?
No, it isn't. I just switched you from presenter. I apologize. You should be, there you are.
Is it back?
Yeah, you're back.
Okay.
Sorry.
Okay. Comparison of ventilation standards. This is important, especially for those of you that are in transition from one to another. This is one that 62-1989, the BPI Building Analyst Standard, Building Analyst Professional, the Building Airflow Standard is a requirement in the BPI BA Building Analyst Professional, and this goes way back to the ASHRAE standard in 1989, so it's very old, and the requirements there were 15 CFM per person and 0.35 air changes per hour for the house. That's a very old standard now. The 2010 standard, 62.2 2010, which is for residential structures. This is the basic equation right here. It's 1% of the area of the floor area, plus 7.5 times the number of bedrooms plus 1. Sometimes instead of bedrooms plus 1, this is referred to as the number of occupants. This assumes a 0.02 or 2% of the floor area is default infiltration for every house, no matter how loose or tight. This has been eliminated in the 2013 version of the standard. There's an alternative compliance path, which is for existing homes only, and there's an infiltration credit for existing homes only. The 2013 version of the standard, notice that the basic equation is different now. It's 3% of the floor area plus 7.5 CFM times the number of bedrooms plus 1. The 2010 version was 1% of the floor area but there's no longer, in the 2013 version, there's no longer a default infiltration. That's what this was here. The 2% of the floor area was added to the 1%, so now the equation is 3% of the floor area. There still is an alternative compliance path, and there still is an infiltration credit. Now, in the 2013 version, there is even a limited infiltration credit for new construction. Now, comparison of the standards. Let's look at some numbers to see how the numbers fall out for different types of houses. Actually, one house, but I've made it 1300 CFM50, and then we've tightened it to 1000 CFM50. It's a 2,000 square foot, two-story dwelling in Cleveland. I chose Cleveland because that's where I grew up. There are 4 bedrooms, and I've got 2 CFM50 values here, 2 tightness levels that we're going to compare. The first is 1300, as I said, and the second tighter level is 1000 CFM50. I've color-coded them so you can see the differences more easily as we go through this. So for whole building ventilation, and this is what I'm talking about as opposed to local or spot ventilation, whole building ventilation, for the 62/1989 standard, for the 1300 CFM50 house in Cleveland, 16 would be the whole building ventilation rate. If we tighten that house to 1000 CFM50, 56 is the whole building ventilation rate. It goes up by approximately 3.5 times, quite significant. 62.2, 2010, the corresponding levels for the 1300 CFM50 house, we get 38 CFM. For the tighter house, 1000 CFM50, we get 47. Of course, there's an increase, but it's not anywhere near as significant as the increase with the older standard. And now to the latest standard, 62.2, 2013. For the looser version of the house, we have 45 CFM. For the tighter version, we have 57. Now notice for the tighter version of the house, all 3 versions of the standard are within the same ballpark. But for the looser version, the older standard is very clearly calls for much less ventilation. Something I want to point out to you again is that the 2010 and 2000 versions of the standard are very close in what they require.
Hey Rick, we have a couple of good questions here already.
Certainly.
One is, could you please define default infiltration?
Yes, the default infiltration is no longer an issue in the 2013 standard. It's gone. But in the 2010 and previous versions of the 62.2 standard, not this standard, not the 62, notice there's no 0.2 here. The 62.2 standard came into being, was first released in 2004. And from 2004 until the most recent version, 2013, there has been what's called the default infiltration, and that default infiltration is for any existing house and any new house, regardless of the tightness level of the house. And that default infiltration was a prescriptive value of 2% of the floor area. It was felt by the committee that that was somewhat arbitrary, and in the 2013 version of the standard that was eliminated. Let's see if I can go back here. That was eliminated, and that's why the basic equation in the 2013 standard Instead of 1% of the floor area, which it was in 2010, it's now 3% of the floor area because we wrapped into it the older default infiltration of 2% of the floor area. I know it's a bit confusing, especially if you think that for all along, since 2004, there has been an infiltration credit that's allowed. But the infiltration credit that you calculate by a blower door test is different from this older default infiltration. I hope that answers the question.
Oh, I think you did a banner job of trying to. There was one good one. I think it's a real practical question from Ken. Which ASHRAE standard keeps a BPI BA or an accredited BPI in compliance with the BPI in audit reporting and home performance work?
That's a good question that before I say anything about it, I want everyone to be clear that I am not an authority on this. I am not the one to answer this question. I will give you my understanding of it. I worked with BPI, as did a couple of other people on the ASHRAE 62.2 committee over the last 6 months to incorporate the 62.2 2013 standard into BPI 1200. We did that. It's Chapter 8. And it's coming up on a slide. And I expected that to become the rule as of the 1st of this year. It's my understanding it did not, and it might be that 1200 standard has still not been released officially. I think it's still in public review. I did hear that as recently as 2 weeks ago, it was someone taking their BPI BA professional examination was tested on 62-1989. So I'm a bit confused about it. It's very important for someone who's being tested or working out in the field to find the answer, the official answer to this very good question. And for that, I would go directly to BPI rather than me. I would ask someone from BPI.
Okay, very good.
Good questions.
All right, we'll let you continue. Go ahead.
Okay. Now, this shows the residential energy dynamics tools. These are free tools available online, and more of this will come up. This is my company. And by putting these side by side, there are a couple of things I wanted to show you. First of all, this is the ASHRAE 62.2 2010 tool. This is the 2013 tool. Part of my objective here is to show you that these two standards and the tools that calculate the ventilation, you can see that they look as though they're the same. The tools line up very nicely. Something great about the newer standard 2013 is we go from about 280 weather stations to over 1,100, and that's a real nice feature for those of you that are using it out in the field. I've entered the data similarly for both of these tools, so we're assuming it's the same house, but we're looking at it with the two different versions. Another objective I have here is to show you, as I did on a previous slide, that the two versions end up with pretty much the same whole building ventilation rate requirement, except if you're in southern states, it's a bit different. This is the result area down here, which I'll show you on the next slide. It's a little bit bigger and a little bit easier to see. So we've got this area down here. The blue labels indicate results. Go to the next slide. It's a little bit easier, a little easier to see. And I put up here some, just to make it easier to see, this is the 2010 version, this is the 2013 version over here. The N factor, some of you know what that is. Notice that it's different. It's the same house, but we have a different N factor. Be careful how you use that N factor. It's my advice that you not use it for anything. Some of you use the N factor to try to find air changes per hour. I suggest strongly that you not use this N factor for that purpose. This N factor is meant for ventilation. Here's the natural airflow. It's calculated differently. In the 2010 version we have 98. In the 2013 version we have 73. Total required ventilation. This comes from the basic equation. The equation that calculated this is 1% of the floor area plus 7.5 CFM times the number of bedrooms plus 1. Over here, it's 3% of the floor area plus 7.5 times the number of bedrooms plus 1. Notice it's a significantly larger number. We have 50, we have 90. The alternative compliance supplement has not changed at all from one version to the other. It's 10.75 in each case. Notice the infiltration credit this is from your blower door test. How loose is the house already? How much air leakage are we getting from natural ventilation? Here we get 29. 2013 version we get 73, significantly larger. So the required whole building mechanical ventilation, 2010 version, 32. 2013 version, a little bit less. Now I've heard people say, well, the default infiltration is gone, so the 2013 version requires much more whole building ventilation. You can see from this example, and one we looked at a little while ago for the Cleveland one, that that's not the case. They are very, very close.
Well, we continue to get more questions here. I'm going to hit you with a couple. Can you explain the alternative compliance supplement?
That's a good question, but it requires a lot to explain that. And what I'm going to do a few slides from now is refer people that are interested in the details of the standard to the seminar, the webinar that I've already mentioned that I did with Bill 3 times, and you'll see a link to that. And I think, Bill, can't you can find that link on your website, can't you? If someone goes there.
Yes, we can. In fact, I'll send it to the group right now, and they could just clip it. I'll send it as a general question, an answer to a question for all.
Yeah, and I think that's the place to go for the answer to that question. And Bill will send that, and you'll also see it will be coming up in my slideshow. I covered that quite well, I hope, I think, in that previous session. Was there another question, Bill?
Yes.
Okay, here. Oh, okay.
What is the... Okay, can you clarify what you meant about not using the N factor?
Well, I'll try. When I said that, I thought, gee, to myself, I thought I shouldn't have said that because that's going to bring up a question. That's hard to answer. A lot of people are interested in the air change per hour, or ACH value. And the problem with ACH is, as you'll see coming up with one of the REDCalc tools, infiltration, natural infiltration, is extremely variable. And ACH is merely an attempt to average, or rather feeble attempt to average that. And the N value, if it isn't used for ventilation, such as in ASHRAE 62.2 2010 or 2013, it's an attempt to find the relationship or establish the relationship between how the house leaks at 50 pascals and how it leaks at under natural conditions on average. So for example, if the N factor is 20 for a particular house, if it's calculated as being 20, and the CFM 50 for that house with the blower door is 2,000, if you take the 2,000 divided by 20, that gives you what number? You're all wondering what that is. And that would give you 100 CFM as a average that would leak in through air leakage. As time goes on and as this is looked at more and more, people are realizing that ACH is really not a good value to use because of its variability. And I hope to show, I'll bring that up again when I show you the advanced infiltration tool from residential energy dynamics. Organizations that require ASHRAE 62.2. This is the first one. The first bullet is the standard work specifications. These are now being integrated more and more into the work we do in the field. Low-income weatherization programs, you'll find these in semi-public programs like utility programs and also private programs. These are considered best practices, and this requires ASHRAE 62.2. There's an EPA document that came out in 2010. The title of it's on the screen, the second bullet, and this document requires ASHRAE 62.2 2010. Another one, weatherization, health, and safety guidance. This is from the Department of Energy. Any of you working with the low-income weatherization program probably know about weatherization program notices. This is the very often quoted and used 11-6, and this requires ASHRAE 62.2 2010, and 62 allows the 2013 version to be used now, and it will be required that every state adopt the 2013 version during the 2014 program year. That's what PY is, program year. Building Performance Institute standard BPI 1200. I mentioned this earlier. I said I'm not very clear myself as to whether this is adopted officially yet or not, but I do know that the draft of this, the one that's out for public review, does include the ASHRAE standard 62.2 2013. So a little bit about 2013 and BPI 1200 Section 8. They are essentially the same. This is the cover of the ASHRAE standard 2013. They changed their logo. I like the old one better, but they didn't ask me. The scope of the 2013 standard, it's single family and multifamily up to 3 stories. So if it's a 4-story multifamily, it is not included. It doesn't come under the scope of this standard. It would come under the scope of 62.1, which is the commercial standard. And here's another one. This is right out of the scope. It does not look at thermal comfort, nor does it look at energy. And another statement out of the standard, acceptable indoor air quality will not necessarily be achieved. The hope is that it will be, but of course there can't be any guarantee. Design details for the standard very briefly, and this is put together for existing dwellings, which I think most of you are working on. Local ventilations is required in bathrooms and kitchens. Simply put, it's 50 CFM for each bathroom, occupant controlled and on only when necessary, and 100 CFM in the kitchen. Again, occupant controlled and on when necessary. Whole building ventilation. These are the equations I've shown you, and there's an alternative compliance supplement, and there is an infiltration credit. This slide shows you some slides from the session that 3 sessions I did with Bill and RETROTEC Tools. This is the address for that YouTube video. You can go there and watch it. It's about an hour and a half long, and it includes the details of compliance with the 2013 2013 version of the standard. This is the title slide right here on the left. Bill, thank you for sending that out. Now, something I want to cover in a little more detail with you is the ASHRAE standard at this time does not look at the differences between balanced and unbalanced ventilation. So I want to look at that with you. What's going on with this? And there are a few things I think you should keep in mind. This is the RETROTEC free tool for the ASHRAE 62 2013 tool for ventilation. And what I've set it up for is an existing house at the Denver, Colorado airport for the weather and shielding factor of 0.59. It's 2,000 square feet, 4 occupants, 2 stories, and the measured CFM 50 is 1,400. These are the results. Notice the total required ventilation rate. This is from the equation, 3% of the floor area plus 7.5 CFM times the number of bedrooms plus 1. We get 90. The infiltration credit is 56, and therefore we subtract that from 90 and we get 34 as the required mechanical ventilation. So that's what I'm starting with. Now, the next slide, this shows part, on the left, this shows part of the Residential Energy Dynamics Advanced Infiltration tool, and that has a section for building has a ventilation system right here at the top. And I've put in 34 to correspond with this house in Denver, 34 CFM, and you can put in the efficiency of the heat recovery ventilator. There's no unbalanced ventilation. And I'm looking at it, the date range is for the entire year, January 1st through December 31st. Here's the stack infiltration, the window infiltration, low, average, and high. The total infiltration, this is based on the latest methods from ASHRAE on calculating infiltration. And here's the ventilation plus infiltration right here. So because I've set the ventilation rate to run all the time at 34, the low right here for ventilation and infiltration is 34. Here's the average. Here's the high. Down here we have a chart that shows you, first of all, the green is the total infiltration, the red is the 34 required ventilation, and the mustard colored is for the combined of infiltration and ventilation. Remember the 90. I'm going to go back. You see this dashed blue line. 90 right here is the total required ventilation. This is what the ASHRAE standards wants to see. Well, this is saying that 56 CFM of that comes from infiltration. So if we want a total of 90 and 56 is coming from natural infiltration, we need to supply 34 with the fan. So this is the line that indicates 34 CFM. This is the 90, and the mustard colored jagged line shows you infiltration plus ventilation. This is for balanced ventilation, 34 CFM. So notice there are times that the combined ventilation and infiltration is significantly above the 90, other times it's below. By the way, I just put up here ventilation electrical usage. This tells us for the balanced ventilation it's about $39 per year to operate this if it's 45, a power rating of 45 watts. Now what I'm going to do, and here are the details of the house, I'm going to go to unbalanced. Let's say that you put in exhaust only. Balanced ventilation up at the top of the tool is now 0, and I put 34 in for unbalanced. Things are different in this chart now, and notice that things are significantly different with the chart down here. They're different in the table, they're different in the chart, the profile is different. We have exactly the same natural infiltration, but because of the way the ventilation works when it's unbalanced, it significantly changes things. By the way, on both tools you can see down where I am at the bottom now, infiltration, heating load, these are in therms, 92.3 therms. Increased load due to ventilation, 6.3 for the unbalanced, and the combined total. If you know the cost per therm, you can find out the cost of the increased load of ventilation if you multiply it times 6.3. And you get the same thing for the balanced over here. So you can see that these are significantly different, balanced and unbalanced. As I said, the standard right now, the ASHRAE standard, does not take account of the difference between balanced and unbalanced. But as you can see with them side by side here, there are significant differences, and this will be one of the, it is right now one of the challenges that the committee must deal with and incorporate into the next version. Now, if there's time when Joe is finished, we're going to come back and we can use the tools and go through a few examples. But right now I'm going to have Bill turn it over to Joe so he can talk about measurement devices. I'll be happy to answer questions if you wish right now, Bill, or go ahead and turn it over to Joe.
Well, first I want to check, Joe, are you ready to pick up the baton here?
Well, 30 seconds. I'm sure there must be a question.
Yes, there are.
For Rick, so yeah, go ahead. Yeah.
Okay, get a lot of questions here. Dale Sherman asks, as the half-fan rule application varies as a function of stack and wind-driven infiltration, why aren't sensors required to compensate properly for unbalanced ventilation?
That sounds like Dale. Yeah. First of all, this tool in the profile, some of you will know what this means, maybe many of you. This is based on quadrature. It's not based on the 0.5 rule. And the 0.5 rule does not affect balanced ventilation over here. It only affects unbalanced. And this tool is not, this tool is set up right now. We will be putting a switch in it so one can switch from one to the other. But it's now using what's called quadrature. And that will affect the profile, and in many cases the profile for balanced for unbalanced, will become closer to what the profile looks like for balanced.
Okay. Joe Nagin's asking, why are they concerned about unbalanced? Do you know why that's a concern?
Well, I'm not sure about that question, what Joe is getting at, but in low-income winterization, for example, and in many home performance programs, what is being done is to save money, they're putting in unbalanced or exhaust-only whole building ventilation. It's very common. It's the least expensive. And I think a big concern is because of lack of money and because in an existing dwelling it's very difficult to put in a balanced ventilation system with ductwork and expensive, that the favored position right now is to put in exhaust-only ventilation. Now, that's not necessarily the best practice, but it's the least expensive, and at this time it does comply with the minimum standards of the ASHRAE 62 to 2010 and 13. And both of those standards are minimum standards.
Okay. Joe, are you ready yet?
I got to turn my mic on to tell you yes.
Okay. I will now make you the presenter. So Joe's going to take us on a little journey here on some testing he's done, some very interesting conclusions and data, and he's done a lot of stuff in the real world here to kind of propel the calculations and the standards forward and make it have contact where the rubber meets the road.
1 second.
While we're waiting, okay, go ahead, please.
All right, hello everyone. I'm the, I guess I'm batting second here on the order. I do actually have a few baseball analogies to kind of go with my presentation to make that complete. Is sound okay, Bill?
Sounds good.
Great. Some of you I know that are in the audience are incredibly sophisticated and maybe were hoping for the grudge match or the battle match or gloves to come off, but my side of it was just kind of remind people about a few of the options that are realistic testing methods, although it sounds like many people are testing already or have their choice of a device. My goal is just kind of go through what are some of the ones that are out there or options or things you might be able to use. Some of this will seem very basic. Some of it may seem a little interesting or, well, I didn't realize that was an option. So I want to thank Bill, who loaned me a variety of great devices. Passive and RETROTEC also has loaned me a powered flow hood. And if you're interested in any of these, you can go to my eBay site and get them before Bill wants them back on Monday. And
What?
So one of the things I wanted to make sure was clear for a lot of people was that we're just talking about mostly exhaust. While I do have all of this great equipment, I am going to play around with the supply and the ductwork challenges that go along with measuring these with these same devices. So today is mostly focused on exhaust and exhaust only, but I just want to illustrate that what was out there between the exhaust versus supply and ductwork. So some of the devices that we have are mostly passive flow measurement devices, which means that somewhere in the device it has a means of measuring pressure and converting that into CFM or feet per minute, or it has some kind of rotary vane or something to, again, convert the air that moves through in a passive manner to give us the CFM that we're after. The one that's not out there as prevalent, but I think it's becoming more of an option or thing people are more considering is some kind of powered flow measurement device. The difference is that when the passive flow is measuring and the pressure gets strong and they have a soft or a cloth cover, when that actually pressure builds up, it can create false pressures that move into the device itself. When you're working with a powered flow measurement, it actually has a fan that will create a reverse pressure and zero out the difference between the pressure that moves through and basically back pressures it or zero pressure and gives you a much accurate measurement. Also comes with some other challenges, but in general, that's actually the most accurate method that's out there. So some of the things we have in our lineup today, I probably mispronounced it, Bill, maybe you can help me. I only read it, haven't pronounced it. Economax, the Tab Master, basically it's a capture hood, and I was surprised how light it was and how efficient it was right out of the box with just a few batteries. We're also going to use the Testo 417 large vane manometer, animeter, sorry. And I also used the flow funnel kits that make this much more possible to do exhaust systems. You get both. You get the little small round one, which actually works really well on some kitchen exhaust, and the square one, which I think they need to reevaluate its size and maybe make it a little bigger. Many of the bathroom exhaust fans, the covers are slightly getting larger and larger. So once you get to 13, 14 inches, many of these and you can use that with Energy Conservatory DG700 or the RETROTEC DM32 or their DM2.
Joe, if you could back up, we lost about 45 to 50 seconds of audio there. If you could back up to that last slide and cover your last point again.
Here or further back?
Right there, just after you mentioned they should have a larger size scoop on that testo device. We missed the next part.
Oh, right.
And we're not hearing you again.
Nothing here?
Now we can hear you, but we missed it again.
It doesn't want to talk. So this is the Energy Conservatory exhaust fan flow meter, and it sounds like it's the one device that the majority of people are owning and using on a regular basis. And I will talk about a way to use it without trying to use the chart on the side also. You can use it with the Energy Conservatory DG700 or the RETROTEC DM32 or the RETROTEC DM2. And probably with a variety of other manometers also, mostly just measuring pressure. Audio there? Okay, good. Some other options you can also use is a duct tester or a duct blaster with either a flange or some other devices like a special flow hood that's actually designed to receive or work with the flange that you normally use with your duct tester or duct blaster. RETROTEC sells this specifically. This is a 2-foot square opening, so it was designed to go over returns and supplies, and they moved more towards an actual powered flow hood, and this is the Anakin Flow Finder, and this is a phenomenal device, and it weighs almost nothing and works in either direction, and we're going to go through all of these today real quick and just kind of show you what they do and my personal take on using them. What are some of the little challenges they all have? Sitting out today, which will not be a part of the actual testing, was the Energy Conservatory Flow Blaster. Some of you may use that, or the Alinor lineup that they have. Also not present is the cardboard box. We will not be discussing the cardboard box today. It is a alternative to the exhaust flow meter that you can actually make your own box and use either meter gauge to actually do that. RETROTEC has a guide about how to make your own device. And also not present is the garbage bag. The garbage bag will not be part of our testing methods today, but it is studying the amount of information that you could find about how to use a garbage bag to test your exhaust supply on either side and in many different ways. In fact, it's the one place where the Canadian mortgage will send you about how to check and find out if your exhaust fan or your supplies are working correctly. And I did have links for these documents that are up here that I sent to Bill. If anybody's interested, they are a great read. So it looked like most people were testing bathroom exhaust fans, and for pretty obvious reasons, it really is one of the easiest ones to get to access. And so I showed all 4 of these kind of quick, and to show you that almost all of them are reading the same, and a variety of little wind would have blown by. That could have been a tiny little bit of difference for the CFM. Clearly, my fan is not producing very well. But in general, you can see, that I could actually reach all of them, and I'm not that tall actually, without actually using anything extra to reach my ceiling, which is a standard size height. So I also made some props to try and do more of a control method. And actually, I went to my garage and found 2 exhaust fans and an old kitchen exhaust fan, and rewired them and put some plywood around them so I could test all these devices and actually see what are some of the challenges or some of the issues that comes along with it. So actually, I did all the props and everything. Actually, I went and bought white paint, but other than that, everything came from my garage. So it was great to go out and, get rid of some stuff. My wife always yells at me, why do we have this old kitchen exhaust fan in the garage? It's for today. So one of the things I did have, which is a beautiful Panasonic Whisper Green exhaust fan. It did not hook up the light kit, but you can see some of the challenges with the shape and the size that comes along with these kind of fans, and they're much more common in the homes you're seeing today that are either fairly new or even the last maybe 5 or even 10 years. And of course, I also have the basic exhaust fan that we all have seen and lived by and drown out our time in the bathroom with. So the exhaust fan flow meter that many of us use, or I'm sure everybody's been exposed to, but if not, I think it's one of the most common devices that it's used, and I agree it's one of the most simplest things you actually can kind of pick up and do. One of the things that we recommend is to actually connect both channels to the actual device, and it'll read the pressure for you and also give you the CFM, whether you use the RETROTEC or the Minneapolis gauge. You don't have to actually refer to the chart on the side. It's a handy way to actually kill 2 birds with 1 stone. So this is the Panasonic. I'll go through some of the devices that I had. Oh, the exhaust flow meter showed up in the middle there by accident. Oh yeah, so that's what we have. All right. On the right is the RETROTEC DM32. It actually has devices for blower door and duct testers for Minneapolis and RETROTEC, and it also has their other devices like the exhaust flow meter, and also the Energy Conservatory obviously has a setting to do that. And you can see I tried to run both ports on both gauges so you can see that it's easily done on both of them. And they were only off by 1 CFM. The Testo had a little bit of a challenge trying to get around the entire opening for this fan. The height really wasn't much of an issue for any of the devices. The challenge was its size. This is a 13-inch cover, and the Testo was only 12 inches. All the other ones actually were able to cover the fan completely to get a reading. So I added some extra foam and was able to make good contacts and get 86, which I felt was a valid reading compared to the other readings I also had got. And the Economax, also, they all had similar readings throughout the entire process. There wasn't any situation where I felt like, oh, this device has got a problem, or doesn't really compare to the other ones. They all read equally. So by no means is there a challenge with any of their internal structure or how they actually read. The other challenges are the device themselves and maybe some of the expense or the process or how you actually maneuver it throughout the structure of the house itself. And this is the last one, which is the flow finder, and you can see it has a 16-inch opening which covers the exhaust fan clearly, and also is cleared, as you can see, through it. And that's actually the adapter that goes on the basic unit, which is in white. Just touch the button once on the side, and it actually will do everything you need automatically. Will compensate for the pressure that's moving through it, spin the fan the opposite direction, and give you a reading, usually within about maybe 10 to 15 seconds, if that. The other one, which is kind of a combination here, is to use the adapter that RETROTEC sells. You could use a large bin from Target or Walmart to do that. That's actually the device itself by itself. And you basically are just going to set it up. And my next slide kind of explains how it works. If it seems strange that you're using a duct tester to read how your fans work. But when it's connected to an exhaust fan, it's going to create negative pressures inside the fan itself. And then when you hook your gauge up and you tell it to set to 0, basically when it goes to 0, it means that it's moving the same amount of air as the exhaust fan does when they're both set to 0. It means that both fans are running pretty much kind of simultaneously. And now that I can read my duct tester, I now have an accurate CFM that must be equivalent to the exhaust fan because it's actually running at a 0 pressure difference. So bathroom exhaust fans, like I said, are very straightforward. Many of us are doing them. I specifically asked Bill to ask about kitchen exhaust fans, and I really wasn't surprised that about half the people were like, not really, and I can only begin to describe some of the challenges that go along with exhaust fans. So for those of you that have one, or if you're not testing them, I highly encourage you to, every time you see a kitchen exhaust fan, to look at the bottom of it, see what the design is, see what are some of the challenges. And I talked to Paul Rayner today about some of the issues, and he thought that all microwaves were, came right back in your face. They didn't really go outside, and I, know that I've had microwaves that did go outside. So there's no hard and fast rules about whether a microwave or any other type of fan does not go outside. In fact, that's kind of the norm, and code is pushing us to actually make sure these ventilate, and now we actually have to test them. So these are
Joe,
the.
can you hear me, Joe? This is Rick Karg. I just wanted to add in here, making this even more complex. That looks a lot like my microwave above my range, and mine does go outside, but some of it comes inside. A little bit comes inside, so it's almost impossible to get a good measurement on these things. Really, really a challenge.
Well, they go from this square opening to a round opening that's got to fit inside the cabinet, and yeah, there's a lot of issues, and a lot of times that stuff isn't sealed no matter how well it might have been installed. And if anybody's put one of these in, the logistics. It's not sloppy or just want to get out of there on a Friday. It's that, how do you put this thing up that really takes two guys to hang it, and also get the ductwork installed and not knock it off when you finally mount it. So yeah, I think there's definitely the cry out to the industry to say, help us with how this works, and how do we make this work even better.
We've got some good dialogue going here. I'll let you finish, Joe, and then we'll get into some questions. I think that we got a lot of inspirational questions here. So finish out, and we might have to go back a couple of slides and point some things out.
Okay, sure. My microwave is a split exhaust intake, and I don't know how other people are resolving how to conquer this. I've tried to measure both sides. In terms of trying to do a comparison, I just covered one side up so that I could just kind of get a consistent number for the unit to work correctly. And on the left-hand image is a reminder that you have restrictions that are mostly based on manufacturer when they go to a certain level, but my reminder was to make sure that you don't have an older stove that has a pilot, because some of the things that I have images of, things would have caught on fire. And make sure you look underneath the exhaust fan, because there's a lot of sticky, gooey stuff that I had to clean off of Bill's equipment last night. So yeah, I definitely make sure it's not a new house anymore, and a lot of strange things happen at this level. Should I continue, Bill, or you want to keep go back to anything?
Keep on going. We'll go back as needed.
Okay, sure. All right. So I covered up one side, so I can now make many of the measurements somewhat consistent, or feel as though I was getting similar numbers to kind of compare them. Again, everything kind of balanced out in general. The images that in the picture may not be exactly the real number that I got, because it's hard to take a picture and get the number you're after. The Testo, the round device that it comes with as the accessory, did well for these, and it also does well with a fan that's in the center, the one I practice on in my dining room / lab. The square one did not actually be able to overcome the openings. I needed one of them. So it's great that they were thinking ahead and how those actually worked. And I did set up my duct tester, and also ran the same type of test. Again, I didn't use the monstrosity adapter that's 2 foot square. I just actually taped on the flange, and was able to set the device to 0 and actually get an accurate CFM that was compared to all the other ones that I did. And there's also the flow finder, which is maybe weighs less than 7 pounds with the actual clear adapter on top of it. It's less than around 5 pounds with the battery and everything you see here. And It does really well for these kind of devices. It was kind of made for this application. Although I got one hand on the right, you actually need two to kind of hold it up tight to make sure you get a good reading. But it is something that is impressive, and when you see it, you'll be stunned on how lightweight it is and how simple it is to work through. And the Economax, sorry, it did not fit. Here's the summary of how they all turned out.
If we could just stop on that slide there, because I did get a question. What's the ballpark pricing on all these different tools? And I'm going to go ahead and give some of that information out here. The exhaust fan flow meter on the left is around $170, but you do need a precision manometer to use with it, so something that can measure in the Pascal range. So whatever device you may already have or one you need to go and purchase, they're at least $600 and sometimes more than that, but you may already have one in the kit you're using. The second device, which is the ACIN Flow Finder Mark II, and a very astute audience member mentioned it is a Mark II flow finder, not the Mark I. It's a redesign and very new and very lightweight, as Joe said. That unit there is around $4,000. The duct tester or duct blaster to use that.
Can I chime in?
Sure, please. Go ahead.
A lot of people have a sticker shock when they hear about that, and I try to remind them about how much they paid for their first infrared camera. Or if you've got a camera and you've had it for 3 or 4 years, that had to have been the same kind of sticker shock. So I think that it has a value that the industry hasn't seen yet in terms of its accuracy and convenience. So I just want to chime in there about the sticker shock. Thanks.
Okay. The duct tester, duct leakage tester, that would be around $1,900 to $2,000, but you may already have one. The rotating vane anemometer is just shy of $600, and those flow funnels that go with it are a couple $100, so that's around a $750, $800 solution. And the flow hood, that comes in around $2,600, but it's not well spent, as you can see from the very good illustration there. We got some good feedback on just even the design of your slides, Joe, so congrats on that. Did you have more to present, or you want me to run back through some of these questions?
No, I do. They may come out because I got a couple of things that I wanted to cover that are different.
Please,
so if I feel it's redundant, I'll go quickly, but yeah. Okay.
Go ahead.
Oh, Rick, you asked me to put this slide in, so I made it happen for you. Okay. There's another way to there's another way to actually evaluate the flow, which is to use a Pitot tube, and you can use this in a variety of ways, from either your dryer, your clothes dryer, to exhaust fan, to that's a basic element of measurement. So I have this illustration here, and there's your follow-up. So Rick, would you like to explain how this works?
Sure. Thank you, Joe. This is a Pitot tube is a you might say the gold standard for measurement. The Pitot tube, if you look at Joe's device here, you can't see my pointer, but it looks like an L, but there's a little spur coming off of one side, so you can hook up both ends of your manometer to it and get a differential pressure. The Pitot tube measures static pressure and total pressure simultaneously, and when one is subtracted from the other with your differential pressure gauge, like that from the Energy Conservatory or from RETROTEC, it gives you velocity pressure. So the Pitot tube is a great device. They're about $60, but they're very limited in that you have to have a pretty good straight run of duct work to get a good reading. And there's a Joe put on the slide here this Pitot tube airflow tool from Residential Energy Dynamics that will calculate for you the velocity pressure, which I just mentioned, is the first input. And it's all explained there, but this is a way to measure a kitchen range hood if you can get at the ductwork. Otherwise, the Pitot tube can't help you. It has to be in a duct.
And in a straight, in a straight and clear path.
That's correct, yes. Thank you, Joe.
Sure. There's a couple other things that I wanted to address, and these are as complicated as what Rick covered, so I can only cover in brief, but this is a more common solution that a lot of people are doing with weatherization and other solutions. In fact, this one kind of in general, Panasonic makes some beautiful devices now that can solve most of our ventilation issues for whole house or make up for lack of fans with these kind of methods. But as you can see, the cover has intake and exhaust at one location that may be in the middle of the hall or wherever it's designed, and it is difficult to actually measure these in terms of if they're balanced or not, or what is it actually impacting besides the nameplate that you're able to guess at. So it's also got a curved surface, which makes it difficult to, because you can't just put your cover over this entire piece. You only want half of it. So there are some challenges, but the industry is finally waking up to some of the issues. I got this from Paul Raymer. Some of them actually now come with pressure ports that you can actually connect directly to your gauge and determine if the system is balanced or not. So I think more and more things should be moving this way. It would seem as though air handlers could also do something like this to do static and a variety of other stuff. And I thought that I would dream for a second and imagine that maybe there's a day when you just pulled up to the house, walked up and put your manometer there, and could find out what kind of pressures were happening on the house. Anyway, I thought it was fun.
And right above that would be the place to plug in your electric car.
Yes, that's right. Right. I just brought this slide up just as a reminder that this is a common solution for a lot of HVAC contractors that want to put in the single damper, connects to the return, and they've got a great device that actually controls this. But how is this measured? And the easiest thing to do would be to send you to the Air Cycler's website, and they actually have specific protocols and conditions on how to determine what this ventilation is or how to actually measure it without taking up the entire rest of the hour. I have a few comments about each one. Do you want to come back to this, or you want me to just go ahead and...
I think that's part of what people are looking for.
Yeah.
Which one is quote-unquote the best one? And that might be hard to answer, and it might be situation dependent, but go ahead and review them, please.
So each one, my goal was to try and find like a couple positives and maybe the negatives that are there. But in general, the capture hood has got to be similar to some of the Alinor or other devices. The drawback for me was that I couldn't use this without the hood itself. I was impressed that I could take 3,000 measurements. It was incredibly lightweight, comes in a great box that I can carry around, runs off 4 or 5 AA batteries. I was stunned. I didn't read the instruction manual, and I was able to turn it on and get CFM out of all the devices I did. And they do have a little like quick guide, but I didn't need to use that either. So I was impressed by its simplicity. And I did have a slide, may not showed up, but it actually is just barely fits through the bathroom door. So it has its logistics. The Testo, the anemometer is a great device. You can use it for a variety of other testing methods, but the real challenge that I found with the small funnel is that it doesn't, it's not able to retain enough volume. When I worked with exhaust fans in the kitchen that actually are close to 100 CFM or more, that it struggled to do that. It kept giving me 92, 93 when I knew that it was over 100 or near 100. And if I lifted it up a little bit and allowed the volume to increase, it would do that. So,
Joe,
yeah.
In fact, I've done testing on that, and I do not recommend using that above 75 CFM. The construction of it just creates too much back pressure.
Right, it does, yeah, right. And the other one I thought is there were nice designs in terms of ergonomics. The one thing I did feel was that when I actually used it on an exhaust fan, I had a hard time actually reading the gauge because of the way the glass was slightly beveled. But I thought I had 71 and I had 31 when I actually looked at the gauge. The good feature about the gauge is it has a min-max. So if I press the button, it will tell me, it'll grab a hold, tells me the max, you can do the mean, the minimum, so I can actually go through what I actually acquired. It is a challenge if you're going to do exhaust fans in the kitchen because you can't see it, so you have to actually be able to press the button. The Energy Conservatory exhaust flow meter is a phenomenal design. You know, I think it's always fair to give credit where credit's due, and it did well, and its numbers were consistent with everything else that had a you know, well-designed or meters or sophisticated parts to it. So I think it carries its own weight in terms of something that you always had with you, but it only does exhaust. There's nothing else that it can do except really just that exhaust type feature. I think many people know what a duct tester or blaster is doing for you already, but there are actually a lot of ways that you may think about how you can creatively use that with either a flow hood adapter to create your own you know, positive pressure, or be creative with a variety of large plastic items that are available at your Walmart. I think once people see the Anakin Flow Finder, that they'll be stunned at how, in the Mark II, just how well it's designed. It comes out of Holland, and it just feels like a well-tuned, a well-thought-through device that's just incredibly lightweight. I press one button, 10 seconds later, I have my CFM results, no matter which way the flow is really going, and then I can save it. And it's very intuitive. It says save, and then actually the next screen is bathroom, kitchen, bedrooms, and a variety of options. And then when you select any of those, it actually gives you a number. So if I had 3 bathrooms, I can store as many as I wanted inside the device. So I thought it was a well-thought-through design, and I think it'll be a while before it comes down in price, but it is something that once you invested in it, you realize how fast you could actually go through a house and all the other devices you can do with this device.
Joe, this is Rick. Could you go back, well, 2 slides now? I'm sorry, I tried to unmute myself. Right there, thank you. I wanted to mention that the bottom one there, the Energy Conservatory exhaust fan flow meter, has a limit of 124 CFM exhaust flow, and if you put it on a more powerful fan, you will get a reading, but that reading is not necessarily correct. So it's important to keep that 124 CFM limit in mind when you're using that device.
Yeah, my response would be that most things I'm determining, I need to know if they are doing 50 or 100 for how I can confirm that this device was meeting the standard somewhat. The other thing about this device is when I'm below 2 pascals, I feel as though my readings are a little challenged. Even though it may still be accurate, I found that if in less than 2, I'll switch the range or the opening. And if you're above 8, you should be changing the opening because you really want to be below 8 pascals. Otherwise, your readings have been are not accurate.
Right.
So I made this for you as a final slide, Rick.
Oh, okay. So this is what you've got in your house. Oh, this.
Yeah, sure, right. I wish my fans did that well.
Yeah. Yes. Okay.
Bill, is there anything else you wanted to track back on?
Yeah. Did you happen to know the rating of your microwave, the one that you measured? The microwave exhaust fan?
No, because it's one of those you know, face burners. I had to, you know, go through the scenario of if it did exhaust to the outside, but it did not. So yeah.
Can you go back to slide 24? Rich Moore is wondering how long did it take to set that up?
Incredibly fast, actually. Here's one of my advice about, you know, everybody who does a duct test, which may be hundreds of you out there, is that I have flex ducts that are in different lengths. I have one that's only 3 feet for when I'm right next to the return. This one here is about maybe 4 to 5 feet, so I got some room to maneuver. And then I've still got a long one that goes up to the ceiling when I need to, but I don't drag around one big long flex duct anymore, unless I need it, and it's not that common. I was able to put the duct tape on fairly quickly and throw the hose in there. Yeah, I thought it might be more of a challenge, but it actually went pretty quick.
Okay. And going back to the pitot tube measurement, I had a question actually. How do you determine the you're going to have a variety of pressures and pressure flows across that duct, or is it really pretty consistent no matter where you are in the duct? I've never tested one like that, so did you see if there was a lot of variation? Because if you pick a different point, you could name it a different flow.
I think the key is whether you've assessed that you're accurately, as best you can, in the middle and pointing it in the right direction. You're right, it is going to like bounce, you know, up, down, and around, but it's not, you can tell if you turned it the wrong direction or if I've pulled it over to the edge. But it's not a stable reading by any means, but it's close enough to go, okay, that's what I got.
Gotcha. Okay.
Bill, may I, this is Rick,
Sure.
just to comment on that. The pitot tube is if you're measuring small duct like a kitchen range hood or a dryer, it's also good for a dryer. It's best to try to get it right in the center of the duct. If you move to the edges, the flow will go down. And the point is to try to average the flow. When this is done in really big duct work, in commercial and industrial applications, there are many tests that are done and then they're averaged. But if you do it in small duct work, do it in the middle, and then as best you can, and then multiply that flow by 90%, and it will give you a pretty good idea of the average flow going through that duct.
Okay, we got one audience member who suggests 1/3 of the way is better than the center. So I'm sure we could probably get into a debate on that, but we're not going to go there right now. But I do agree they can't be near the walls where there's going to be drag. Okay, middle time is about 90% good, according to Dale, who made that comment. How about measuring outside, where the exit is for the flow hood? What do you guys got to say about that? Where the
I'll go. Yeah, the challenges are that many of these devices don't do well when they're actually pressurized versus allowing a pressure to run through them. You know, the pitot tube exception, but most of them are, even as passive, they don't do well when actually air is pressurized into them. So it can be done, but you'll find that many of these, you could read the exact same fan on both sides, and it's not going to read the same as you would have thought. Like, oh, it's just, you know, air moving in, air moving through. It's not always that accurate. And the logistics are how easy is it to get to that outside location where it's got siding or it's up high. You know, I think there's means to do that. I think some people that have ERVs or HRVs, they're kind of forced to sometimes do that to actually use that as a measurement.
Yeah, and I'm getting the same feedback from people responding, saying safety ceiling supply measurements that it can be very inaccurate when you're trying to do wall or roof cap measurements.
Well, I mean, you pointed out something that's like, you know, what is it that you're measuring? I mean,
yeah.
Is it a safety issue? Is it a life safety issue? Is it something that's going to actually impact you know, the occupants or the durability? And if it's 100 CFM versus 95 CFM, is my personal feeling is that really going to make a huge difference? Or if I'm finding out why it should have not exceeded or come close to what its nameplate was, or it's a crimped duct or a poor install somewhere besides the fan. You know, there's two other methods that I used to use when I was not doing is the paper test. You put a piece of paper underneath the exhaust in the kitchen, and if it holds it up, then it's doing pretty good. Piece of toilet paper in the bathroom, if it holds it up, then it's doing pretty good. So.
Gotcha.
I want to go back to the question about measuring outside. I've been with a number of people in the field that have sworn that their energy conservatory exhaust fan flow meter measures correctly on the outside, which is a supply situation. It's an exhaust fan they're trying to measure on the outside. I I don't think it does. I think there might be circumstances where the numbers inside and outside agree, but I think that's not a professional way to do it, and it's best to stick with the instructions from the manufacturer rather than going with circumstance out in the field.
I agree. I think you need to think on your feet, but you should always have the source. Don't be the source. Don't be the person who decides this is a testing method. Be the person who followed the criteria or the guide, and you know, make sure you're able to make some accommodations. But I've always gone back to this is the source. This is the document that I follow. This is the manufacturer's recommendations.
And if you're not measuring now, you probably will be in the future, because, as I said early on, the ASHRAE standard requires measurement if you're going to leave a fan in. You need to measure that.
Based on the ERVs and others coming up with ports, I think that's going to become the wave of the future. I do think that not only would it be something that was a smart idea, but if a contractor knew that this was how I could, you know, confirm that it was working correctly, I think that's got to move a high criteria to the top of the line as to, you know, Panasonic, if you're out there, you know.
Right. I don't know if they are.
They're everywhere.
Yeah. Someone did suggest the flow hood device could work by removing the hood and fashioning a piece of craft board to fit under the range hood with a cutout for the device. I think you would be making a measurement, but I don't think it would be a calibrated measurement. So it would be a number that could be used for comparison, but each one would be like a unique piece of art. They would all be different.
But I do think if I was back doing weatherization or doing this regularly, I would have come up with a variety of, you know, little things in my truck that, like, oh, this is a split exhaust, and I would have a box that, because this width is always the same and this depth is very similar, that I would be able to go get that box and have weather stripping on it and know that that's what I use for this method. If it was a single one that was challenged, you just cover the whole fan, is what a lot of people do with either a rigid board or something that has the opening for the device you live by.
Right. Rick, did you want to go back and look at some calculations? I'm still getting questions here, but I think there was another point you wanted to cover. Kind of wanted to wrap back around, Rick.
Well, what I might do is suggest a way to measure a kitchen range hood in a fairly tight house with a free method that's online. But I think if there are more questions for Joe about measurement, let's at least take a couple more of those, and then I can show this other method that might be helpful to some people.
Okay. Did you ever try using the vane anemometer without that funnel kit to get a CFM reading, using it in the traverse mode or the snapshot mode?
I did not, mostly because I just felt as though, because I had the better device to use. But I am going to do something that deals with supply, so I can reevaluate the traverse method or options that it actually has when we put the next half of the webinar together on actually measuring supply.
Bill, I have done that with an anemometer, and the real difficulty with that is entering into the device the free open area of the grill that's involved. Right. And if you get that wrong, your reading will be wrong.
Right.
And that has to be in square feet, and that's sometimes very, very difficult, if not impossible, to get accurate unless you have it stamped on the particular grill or register that you're trying to measure, or fan face. Very difficult to do.
Okay. What are the presenter's opinions on providing fresh air by connecting a duct between the outside and the HVAC return duct? Would you recommend a damper? What are the implications of pressurizing homes in a heating climate?
Well, I think the slide that Joe just went to is ideal. An air cycler has a system for this. Remember that if this is done, that you're using the blower on the furnace for your fan, for your ventilation fan, and unless it's an efficient DCM motor, that could be very costly. And you're also pressurizing the house, and keep that in mind. So this is not always the best thing to do in cold climates, but it's a very attractive solution because it's inexpensive, and it's a well-distributed fresh air that's coming in because it's going through the ductwork of the furnace, and that's an advantage.
Yeah, I do see this as a very common install, and the simplest method is what a lot of contractors want. I also think that if they don't inform the homeowner as to how this works, it can become a disaster where they just turn it off.
Okay. How would you set up the duct tester in a kitchen? I guess that you had that picture, Joe. I think they're talking about.
I'll go back to it. Sure.
Yeah. If you could just describe the steps you took briefly.
Yeah, so I try to put the image on the right to show that I just basically taped the flange to the opening. If it was a single opening, it actually is a lot easier to do. Pardon me. One issue that in fact, you can comment on this, Rick, is the requirements say that you're supposed to leave the filter in. And to me, that always meant that it was a new house or a new unit. But to me, if I go to a house and it has a dirty filter, I take it out because it does not seem to be an effective way of testing something that I've already restricted because I know it's a maintenance issue that can be fixed. So here I just actually taped it on. Again, I used a short section of flex. Once you connect either duct tester, you can see that it will come up with a negative pressure anywhere from like 30 to 50 if you're getting really good movement through your fan. So it's a negative 40, and then either use the speed control on the RETROTEC or the Minneapolis or the RETROTEC. You can just do set to 0, and it will go to 0. Sometimes it can overshoot, so you want to be careful that you're not overpressurizing, but you can watch it actually work its way down and see your final number.
I think that's the way you can do it. If you're trying to find out the CFM of this for the ASHRAE standard, it's of course what you'd have to do with a unit like this is get both of the filters there. That's where the air is going, and that's tough to do. In this, I can't point it out because it's Joe's got control, but you could put a piece of cardboard across where the cabinets drop below the bottom of the microwave, and then connect the flange that he's got there to that piece of cardboard and seal that off so that you've got access to both of the vents above the filters simultaneously. I think it's probably better to use the filters. This is not combustion safety testing. We're trying to find out the real normal flow here, and probably better to leave the filters on. But clean filters would be better than dirty filters. That's not addressed in the ASHRAE standard.
Yeah, one of the person in the audience, Chris Stratton from Lawrence Berkeley Labs, who's done a lot of airflow testing and research, made exactly that comment. It's better to leave the filter in, otherwise it's not really a run condition.
1 second.
And there will be, coming up in the ASHRAE standard, eventually, this is starting to be discussed, and Lawrence Berkeley Labs is doing testing on capture efficiency of kitchen ranged hoods, and that will become part of this in the future.
Joe, you wanted to show something? Yeah.
Yeah, this was the filter that my kitchen exhaust fan that I have in the garage had. and clearly they were using it in this manner, but I could hold it up to light and barely see through it. So I think that I agree that the filter should be left in, but there's some common condition that should be applied there, that this would have maybe done 10 CFM, if that, with the filter in place.
Okay.
I think the reality is that you need to be creative at this stage in the game with kitchen exhaust fans. They're all a little slightly different, and the more ingenious and handy you are in your garage, you'll be more productive in the field.
Bill, would you mind, speaking of being creative, I think this might be helpful at this point if you hand over control to me.
Okay. Of the entire company, Bill.
There you go. See ya, guys.
What I've got here is this is one of the REDCalc free tools, and I want to caution you about using this, but if it's a tight house, this might work quite well. We don't recommend this in the user manual, but we've heard from a number of people that are using this with pretty good success, and more people are verifying it with some of the measurement devices that Joe used. This is a tool that can be used to, here's your building leakage. This can be used for various things. You can solve for any one of these three values: building leakage, if you have the other two, exhaust flow, or depressurization. Let's solve for exhaust flow. I've filled this in. This is a big deal right here. You have to get this right, and if you can do a multi-point blower door test, you can get a very good idea of what the pressure exponent is, sometimes called the flow exponent. So you put that in that box, put in the CFM 50 value. I put in 1,000. Again, tighter houses would work better. And the depressurization that the kitchen exhaust fan creates, you don't have to put the negative there, when it's running, I put that in here. You could get that from your manometer, and it calculates the exhaust flow of the fan that's running. Of course, the blower door is off at this point and plugged, but you do have to put the blower door reading here. So this gives you, as if you click or touch any of the labels, it tells you what it's about. This gives you a reading on what the actual flow is out of the house with that exhaust fan.
Where does the pressure exponent come from?
The pressure exponent is another way of, well, it comes from multi-point blower door test. If you only do a single point test, just use a 0.65. But if you do a multi-point test, like using the Energy Conservatory TechTite, and I assume that RETROTEC has an analogous software, you put the pressure exponent that the software generates for you from a multi-point blower door test, say at a house pressure of 10, then 20, then 30, then 40, then 50 pascals. TechTite does that automatically. It takes control of the blower door, and it gives you the pressure exponent. It's the slope of the house leakage curve is what that is. But if you don't know what it is, just use 0.65. If you do know what it is, put it in there. Say it's 0.68. It varies anywhere from 0.5 to 1. And I put that in there, and you notice I changed the flow exponent and the value of the exhaust flow of the kitchen fan changed a bit. So this is another way without a measurement device that you could use. It's probably better than nothing, but I do caution you, it's important to have a flow exponent if you are able to.
This works on smaller, tighter houses. I tried it on my house, and there was no way that it would even. On a looser house, it will not work. There's just too much going on. It will not work. Can you explain how? Because several people are confused about how you get your number here, Rick.
Which number, Joe?
Your depressurization pascals.
The depressurization pascals, well, I go to the house, I do a multi-point blower door test, and I find that the flow exponent is 0.68. So I enter that. In the process of doing the blower door test, I enter the house CFM 50, whole house CFM 50. I find it's 1,000. Now I turn the blower door off, I plug the fan in the blower door, I turn on the exhaust fan, and I find that that exhaust fan running in the kitchen creates a pressure between the house and the outdoors of negative 2.2. In this tool, I don't have to put the negative. So that's where that comes from. I am solving, I hit the radio button here for exhaust flow. I'm solving for exhaust flow, so it gives me about 120 CFM for that kitchen exhaust fan. So
yeah, I think for passive house, yeah, those are very clear. For passive houses, this is actually a viable method of testing their exhaust fan.
I think it is, yes.
Your tools are phenomenal, Rick. I always go to your site every now and then. I wish I had more time to just actually hang out and use these things more frequently. But I and the hundreds of people that came today and the thousands that did not, thank you for your diligence and efforts, because it makes a world of difference for all of us. It's huge. Thanks.
Thank you, Joe.
Yeah, we're getting a lot of praise and thanks and great slides, great calculators, great explanations, great putting this together. People are really liking this. We have gone over the 90 minutes. I will keep it open for about another 5 minutes or so. If there's any more burning questions or issues out there, if the presenters have something to cover, but everyone who has attended has stayed long enough to achieve their 1.5 BPICU credits, if that's important. So a lot of people are exiting. We had up to 470 people. We're now down to 384, so there's been a lot of retention here even throughout the last few minutes. So Rick and or Joe, do you have one more point you want to cover? Or do you want to leave it up to what feedback I get here?
Well, I would like to just, when I do these with RETROTEC, I try and ask, what else are people looking for, or what part of this would they like to be pulled out to be a much longer segment?
Okay, so anyone want to say if they want a follow-up, just write the words follow-up in your question and write what that topic is, and we'll pick them up afterwards when we go through and do the post-mortem on this event.
It's a very good idea. Yeah, that's a good thing to ask for. Thank you, Joe.
And just for everyone, I've posted a couple times written-wise, but we're also going to take the recording, which is still going on right now. We're going to take this recording and post it on our YouTube channel, send you the link, and then I'll gather the slides from the two presenters and provide PDFs of those for those that want to have the slides retained also.
Hey, Bill, I don't know if you can hear me on my mic. I just wanted to say a couple words.
Sure, Colin, go ahead. This is Colin Gall, president of RETROTEC.
Yeah, I've been answering a few questions in the background here. One alternative that I've used before, which is quite an accurate way to measure these exhaust fans, is to do a blower door test at, let's say, minus 10 pascals, and then with the kitchen exhaust on, let's say, for example, and then cover it and take another reading. So let's say your difference is 100 CFM. Then you pressurize the house, and you do the same thing, cover on cover. Let's say your difference is 150 CFM. You take those two differences and you add them and divide by 2, and it's a very, very accurate way of measuring an exhaust fan, its actual exhaust quantity. And by doing it both ways, you compensate for the fact that on one case you're pushing the air into the other way you're pulling it away from the fan. So I think that would, if you people out there could try that and kind of validate it, it would be a great little calculator for Rick to add if he thinks that it's appropriate. The other comment, sure?
That's a good method. Sounds good.
It's one that we have used in enclosure testing for fire enclosures for measuring HVAC impact and how it sucks agents in and out of rooms and so on, and it seems to work pretty well. The other comment I wanted to make is Just about any one of these little boxes work great on exhaust flows. As I've said in a bunch of the messages here, they're really easy to measure, and you can just take any old cardboard box or anything and cut a hole in it, and on our gauge, or you can just use a formula. I think Rick's got one on the site here, and you can calculate the flow going through the hole if you just measure the pressure across the hole. When you're doing the same thing on supplies, the numbers go all over the map. And on some of my webinars, I did it live, and I was getting differences of about 30–40%, which is pretty common. Whenever something blows into your measurement device, it becomes extremely difficult to measure. So when you're using a power device, it has one section in there that neutralizes the pressure, and then it kind of squeezes it through a smaller orifice, and a fan sucks the air back to zero. And those devices can be quite accurate on supply flows, which are really the toughies. The other place where these powered flow hoods work really, really well is, let's say we've got a return coming up and it branches off into one room, and on the other side is the other room, and sometimes you can see right through. If you put your hood over top of that, any kind of passive device there says, to hell with you, I'll go through the other hole. It could go through one hole or the other one just as easily, and you really, really undermeasure returns when you're using a non-powered devices. So that's something you'll notice when you start playing with these devices, and the tricky measurements that you make is where they really shine. I've made measurements of exhaust fans where I got holes around it big enough to put my hand in it, and it's still measuring the same flows that I would have gotten after I covered it with foam and so on. So you can really stretch the envelope with some of these powered devices, and that's really where their value comes in, is that anyone can measure exhaust flows, but trying to measure exhaust flows with poor sealing and try to measure supply flows, that's a different story. I'm done.
Okay. Colin, thank you. And actually, a couple of people would like you to write up that alternative method you just explained, the depressurization and also pressurization range hood testing, because I think it was a little bit hard for them to capture. If you wouldn't mind doing that, I would include that in a follow-up message to all the attendees.
I'll send you a copy, Bill.
Fantastic. Thank you. Okay, I'm going to stop the recording here. We're just going to pick up any other questions.